Hello, geometry students. So we're going to look at special right triangles and solving using similar triangles. So this is something that we practiced a little bit in class, but I just want to have a couple more reminders for you so you can use these to refer back to. So first off, we have our two special right triangles that we've looked at so far, and that is a 45-45-90 triangle and a 30-60-90 triangle. Now take a moment to put these at the top of your paper. We've looked at these before, and we noticed that there is a common ratio between all of the sides. We noticed for the 45-45-90 that both of the legs are always going to be congruent. So the ratio here, we know that if this side's 1, then the other side here, the other leg, will also be 1. Now we could use the Pythagorean theorem to solve this, but when we do, we'll end up with our hypotenuse of square root of 2. So this we can say is similar to all other triangles with 45-45-90 angles because of angle-angle. So remember how angle-angle similarity, if we have two angles that are congruent, that means that our triangles are similar. So if I know that even just this side and this side are congruent and my angle is 90 degrees, then they must be similar because the other angles would have to be 45. So we're going to use similar triangles to solve those. The other one, we have a 30-60-90, and across from the 30, our scale would give us 1. Across our hypotenuse would be 2, and then our longer leg would be square root of 3. So these are similar triangles that we'll use to solve any question. So here are two questions that we have. So notice how on this triangle here, we have a 4 as one of our legs. Well, we already know that the other leg then has to equal 4. But what we can do is we can always use proportions to help us solve. So when I think about this, I have 4 over, notice where 4 is? Be 4 over 1 would equal x over 1. So 4 over 1 equals x over 1. So this is one way I could solve for x. Now, if I cross multiply here, we know that x is just going to equal 4. So that one, it's not necessary that we set up this question and to solve for x in this way, but you can set it up this way to solve for everything. We could also then set up a proportion to solve for y. As soon as I figure out how to delete this. There we go. So we still know that 4 compares with 1, and then y compares with square root of 2. So we would say, first of all, we would say that x equals 4. And then to find y, we have 4 over 1 equals y over the square root of 2. So where that comes from, we have 4 over 1 equals y over the square root of 2. And then we'll cross multiply to solve this. So 1 times y just becomes y. And y equals 4 times the square root of 2, because we can't do anything more with that. So we just answered both of those questions. Now, with a 45-45-90, we could also have a question that might be a little more challenging. So let's try one of those. Let's see. If I have, instead of y here, let's say that this side length was 8. And I just want to solve for x. Well, and I can set up the proportion. 8 over, remember 8's the hypotenuse here, so 8 over square root of 2 equals equals x, so we have to be on the same triangle as where the 8 was, x over 1. So now if I cross multiply, well, we know that x over 1 is the same as x, and on the left side we know we can have to rationalize that denominator. So let's do that now. So we get 8 times the square root of 2 over 2 equals x. So then we can simplify this, and we'll end up with x equaling 4 times the square root of 2. Remember that you can only simplify that 8 and that 2. You can't simplify within that radical because the denominator isn't within a radical. Okay? So that is our answer for this side over here. Now let's take a 30, 60, 90 triangle. So similarly, we know 6 is associated with 2. So we'd say 6 over 2 equals, and we want to solve for x first, x over 1. So I can simplify, I'll end up with x equals 3. Now if I want to solve for y, I'm going to move this first. So there's my x. For y, I can still use 6. So I could say 6 over 2 equals y over the square root of 3. Because, so notice the cursor as I'm going through here. So 6 is associated with 2, and y is associated with the square root of 3. So now we can simplify. 6 over 2, we get 3. And to solve for y, or to get y by itself, we're going to multiply the square root of 3 on both sides. So we'll end up with y equals 3 times the square root of 3. Now, we can use the same technique if we had a little more challenging of a question. So let's try one more. Trying to delete these. We'll see if it works. Now we can delete them. There we go. All right. So let's change this. Let's move our y up here. And let's say that our longer leg is 4. Now, I'm going to solve for x first. It doesn't matter which one I solve for first, but I'm going to solve for it first. So I have 4 over, and 4 is associated with the square root of 3, because they are both opposite of the 60-degree angle. So 4 over square root of 3 equals x over 1. Now, x over 1 is just x. So I need to rationalize this denominator. So I have x equals 4 times over the square root of 3. And to rationalize the denominator, I'm going to multiply top and bottom by square root of 3. So we get x equals 4 times the square root of 3 over 3. And that's our answer there. Now, to solve for y, we're going to use a similar comparison. So I know 4 is associated with the square root of 3. So I'm going to use that also. So I'm going to say 4 over square root of 3. I'm going to start it just the same. But I'm going to change this. I'm going to say equals y, and y is associated with 2. So equals y over 2. So I'm going to get rid of this just because of space. And then we can solve for y. So x, I'm going to just leave this over here. Whoop. And then we'll replace this part with y over 2. Alright, so now, because I can't simplify this right side, I'm going to cross multiply. So I get y times the square root of 3 equals 8. And then, to get y by itself, I want to divide by square root of 3. These square root of 3's cancel out. On the right side, I need to then rationalize the denominator. So I multiply top and bottom by square root of 3. And I get y equals 8 times the square root of 3 over 3. Now, if you're starting to see some patterns, that works as well. This is always a go-to to use, but there are patterns that you might see throughout that would help to make this maybe even a bit simpler for you to solve. But using similar triangles, these triangles at the top to help solve every single time will get you to the correct answer. Thank you for watching. I'll talk to you later.